chapter we started on Tuesday, and then you guys did a practice on Wednesday, is logarithms. We talked about what a log is, why we need one, why we use one, and how, more importantly, how does it work, right? A log has the same parts as an exponent. They're just rearranged different. Still has a base, has an exponent, has an answer. They're just rearranged. Okay? All right, phones, put those away. Phones, turn them over, eyes up here. Here we go. Okay, so the difference with today, all of those rules still apply. These still apply. That's why I left it up here. The difference today is that we have a special type of log. It's called a natural log. Natural log. Okay? The difference between a regular log, like the ones we saw in the last set of notes that we did, these are regular logs, right? Natural log has a base of e. We talked about e a little bit last chapter. E is with the formula. We talked about e. E is a number. It's around 2.7, around there. Okay. So anytime you have a natural log, that just means a log with a base of e. That's all it means. Okay. It's kind of like when the log doesn't have a base, it's 10. Remember common log? We talked about that last time. This just has a base of e. So everything still applies. All the rules still apply. So the first thing you do anytime you see ln, change it to exactly this. They're exactly the same. Okay? Why is it? So it's called natural log, but it's ln. I don't know why it's ln and not nl. I really don't. I don't know why. Probably has something to do with Latin. The way you pronounce natural log starts with an L and N because most of the stuff was based off the Latin language. So I don't know. I honestly, I don't know why. But that's so ln means natural log. Okay. So the first thing you do, swap them. I don't want that. I want this. That's okay. Okay. So let's look at 1A. We saw questions like this yesterday. You saw questions like this. The only difference is it didn't say ln. It said log base of whatever, right? So the first thing you're going to do is you're going to change it, swap it out. Swap out this guy for a log with a base of e. Because it is a log. It just has a base of e. Okay? Now put the rest. E is the answer part. That e right there that I didn't highlight, that's the answer part. What we have to figure out is the exponent part, kind of like you guys did yesterday. Now it's a problem that you did yesterday. So how do I solve this? Change it to an exponent. Okay, you can use the loop trick. The loop trick said, start with the base, then go over here, then come back around. So we have e to the x power equals e. So I just swapped them around. Instead of a log, I put the base over here, e. Put the answer over here, also e. Put the exponent up here, x. Okay. So now, this guy has a power of x. What is power does this guy have? Yeah, if there is no power, it's always 1, right? So how do I make them equal? What do I need to make x equal to? What power I need to put here to make them the same? So the missing power is 1. The missing exponent is 1. If it had a 1, they'd be the same. Okay? Let's look at the next one. The next one has a natural log. So the first thing I'm going to do, before I even try to decide how to solve this, I'm going to rewrite it so that it has a log instead of a natural log. and it's missing an exponent part. Again. Okay, get rid of the log. How do I do that? Loop trick. E to the x power equals the answer part, which is e to the 6th power. What is the missing power? 6. So the missing power has to be 6 for them to be equal. So it's exactly the same as you guys have been doing. The only difference is you have that natural log part. Well, change it. Change it to a log. Change it to a log with a base of e. All right, so now let's do this one. Again, first thing, I don't want ln, I want log with a base of e. This guy's a fraction. Missing that part. So to get that missing part over here, I have to do the loop. Okay. E to the x power equals 1 over e squared. So I know some of you guys in your head, you already know what the power is going to be. Some of you can do that. Go for it. Some of you are like, I still don't know. Well, this is how you found out. Okay, so my goal is to make both sides the same. I want them to look exactly the same, or as close to the same as they can. I see that this guy over here to the right, it's got a fraction. So how do I move this guy up so it doesn't have a fraction anymore? How do I get this guy, how do I move it up to the top floor? What are the rules for moving? When I move it up to the top floor, it has to have a negative power. Good. So when I move it up to the top floor, it doesn't need the fraction anymore because it's on the top floor now. What's the missing power? -2. Okay. Some of you can see it from here. Some of you can see it, oh, it's negative and it's squared. Go for it. That's fine. But I know some people, sometimes it's hard to see, so I just take that extra step if you need to. Okay. All right, a couple more of these type. Now we got a root. So this one, I'm going to change it. Everything else stays the same. So log with a base of e, and then it's the 3rd root of e squared. And I have to figure out what that is equal to. So I'm still finding the exponent part. Loop. E to the x power equals the 3rd root of e squared. Well, one of them doesn't have a root and the other does. How can I rewrite the root part so it doesn't have a root anymore? What power do I have to give it so it doesn't have a root anymore? A fraction power, right? Which fraction power would this guy get? 2/3, yeah, 2/3. Because it has a power of 2 and a root of 3. That's why we give it a fraction. If it has both, it gets a fraction. Now, what's the missing power? 2/3. Okay. Try the last one. Try the last one on your own. Try letter E on your own. See what you get. Give you a hint. This is the first step. Are there pencils over there? Yeah. Okay, so you change it to a log with a base of e. loop, e to the x power equals 1 over e. Got another fraction. Well, first of all, what power does the e on the bottom have? 1. So again, I need to move it up. It needs to move up. So to do that, I got to change it to a -1 power. So now to make them the same, they both need to have a power of -1. Done. That's the missing power. Okay. Okay, that's part of it. The other part is solving. Okay, we're going to solve now. Okay, so first one, example number 1, use the properties of logs to condense, make smaller. Okay, so condense means we're going to go left to right. So we're going to go from this side over to this one. Which ones are we going to use? Whichever ones we need to. So let's look at 1a. I have plus. Plus means product rule. So I'm going to use product rule. Sometime in this problem, I'm going to use product rule. I also have a z in front. That's power rule. Okay? So the first thing I need to do is put the z back. The z is in front. That came from up here. That's what the product rule or the power rule says. That came from there. Okay? So let me rewrite this. Log of b plus log of d to the z power. So the first thing is I put the power back. Okay? Well, I have 2 logs. I have a log over here and a log over here. I want to condense them to make 1 log. Well, it has a plus in the middle. Product property says I can combine them using multiplication. That's what I'm going to do. Okay? So instead of 2 logs, I have 1 log. And I'm going to combine b and d to the z power using multiplication. Done. Okay. It's condensed. I started with multiple logs and I ended up with 1 log. That's condensed, make smaller. Okay. B now, B. Well, I have subtraction and I also have a number, something in front. This guy came from up here because that's what the power property says. The power property says if I have anything in front of a log, it came from the power. So I'm going to move that power back. So log of k to the 5th minus log of q. I have minus. Quotient rule says you can combine those two by using division. So that's what I'm going to do. I only need a single log. I'm going to have division now. What am I going to divide? On top, it's going to be k to the 5th because that came first. On bottom, it's q. I can't divide them because they're both different letters. So you're done. That's how we condense. That's how we make things smaller. Okay? Number 2 is the opposite. They're already condensed. Expand them. We're going to use the same properties. Okay. So now we're not starting on the left side. We're starting on the right side. So you're going to see multiplication. You're going to see division. You're going to see powers, right? 2a, I see multiplication. 5 times a, or 5 times x to the 4th. And I see a power. So the first thing I'm going to do is I'm going to use the product property to expand them. So instead of 1 log, I'm going to give them 2. So log of 5 plus log of x to the 4th. Because those are the two things that were being multiplied. If there were 3 things, let's say there was y out here, then I would have a third log plus log y, but there's only 2. Okay? Last thing. We said the power, right? The power only goes with x. So I'm only going to move the power in front of this log. I don't have to do it in front of both because 5 didn't have a power. Done. Okay. All right. Letter B. Well, I got division and I have powers. So when you're expanding, always start with either product or quotient. Finish with powers. When you're condensing, you're going to go down. When you're expanding, you're going to go up. So the first thing I'm going to do is split them up. So right now they're here. Split them up using subtraction. Okay. I use subtraction because there was division. Division and subtraction go together. Last thing, powers. They each have a power, so they go in the front. Okay. Letter C. What's different about letter C that A and B didn't have? Square root has a root. And there's 3 terms, right? There's 3 guys. I have a y, an x, and a z. Okay? Well, we're expanding. So the first thing I'm going to do is I'm going to split them up using division. Okay? So that means I'm going to give them each a log and put a subtraction in the middle. So I have a log of the top minus a log of the bottom. Okay? Still have multiplication here. So I need to break those up. So the first guy is good for right now. But this guy I have to break up using multiplication, changing multiplication to addition. And they were together on the bottom, so I'm going to put parentheses around them. They were together on the bottom. So that's why I put parentheses around them. Okay. Last thing is powers. I know this guy, Z, has a power of 3, right? I know X has a power of 5. What about Y? What power does Y have? So I'm going to do a little side thing. If I wanted to get rid of the root, what power would I have to give Y? No, you're close. What power would I have to give Y if I wanted to get rid of the root? 3 over 2. 3 over 2. Because 3, it's got the power, and then 2, you guys were saying 2. That's right, but it goes on the bottom. So this is the same as 3 over 2. Okay. So that means the power is going to come in the front, 3 over 2. Power comes in the front. Power comes in the front. Done. That's expanded. Right? We started with this, very compact. We finished with that. Okay. All right. Okay, here we go. Phones, let's put the phones away, turn them over. We don't need phones today. Okay, so I have log and log. They want a single log, so that's another way of saying condense. I have to condense these guys. The only difference between these guys and the last one is that you have more numbers than letters. This side, the left side, we had more letters than numbers. It's the opposite over here. It's the same thing though. Okay, I got powers, or a power, I'm going to put back there. So I have log with a base of b, 2 to the third power, plus means multiplication. So I'm going to multiply the logs. 2 to the third times 10. Well, those are numbers. 2 to the third is 2 times 2, which is 4, times another 2, which is 8. 8 times 10 is 80. Done. Okay. Excellent. Well, this one's got a power. Put it back. Okay. It's got a subtraction. Subtraction, we're going to use the quotient rule, use division. 8 divided by 2 squared. Well, 2 squared is 4. 8 divided by 4, 2. Done. Okay. Same thing, just using numbers. These we had more numbers, so we could multiply them, divide them, all that good stuff. Okay. 4, the last one, 4. 4 is the same as the ones. The only